Incredible has superhuman strength, which he uses to save lives. We decided to test how realistic his super strength is by understanding the physics behind it.
Mr. Incredible's primary superpower is super strength. He is seen stopping moving trains at top speed with little difficulty.
In the train scenario, the mass of the train is 4,000 kilograms and the acceleration is 1.6 meters a second square. The forces acting on it are gravity, normal, friction, and applied force. We calculated the net force by multiplying the mass times acceleration, which gave us 6,400 newtons. The force of gravity was the mass times 9.8. This gave us 39,200 newtons, which is also the normal force. To calculate friction, we multiplied the kinetic force of steel on steel by the normal force and got 16,464 newtons left. To find the applied force, we added the net force and friction. This gave us a sum of 22,864 newtons right. Therefore, Mr. Incredible would have to exert a force of 22,864 newtons to stop the moving train.
In the real world, no human would be able to stop a moving train because it's physically impossible.
In order for Mr. Incredible to stop the moving train, his mass or his acceleration would have to change.
Mr. Incredible's acceleration is 3 meters a second square and his mass is 110 kilograms. To find the net force of 330 kgs, we multiplied his mass by his acceleration. First, we found his force of gravity, mass times 9.8, which gave us 1078 newtons. This is also the normal force. Then we calculated the force of friction, kinetic times normal force, and got 647 newtons. To find Mr. Incredible's new net force, we have to add the applied force of the train and Mr. Incredible's force of friction. This gave us the net force of 22,217 newtons. Finally, to find the new acceleration, we divided the net force by Mr. Incredible's mass to give us a product of 202 meters a second square. This would have to be his acceleration to stop the train.
Mr. Incredible begins his workout by lifting a series of heavy objects. Our example will focus on locomotives.
The mass of the train is 4,000 kilograms. The acceleration is 0. Therefore, the net force is also 0. To find the force of gravity, we multiplied the mass times 9.8, which gave us 39,200 newtons down. This is also the normal force. Therefore, Mr. Incredible must exert a force greater than 39,200 newtons up to lift the train.
In the real world, this would be impossible because no human would be able to exert a force that great. Mr. Incredible's super strength is shown when he pushes his boss towards the wall, causing the boss to go through the wall.
You were this close to losing your...
This scenario is impossible because Mr. Incredible would not be able to apply a force great enough for the boss to break through the wall. However, if this were to happen, the force applied to the boss would kill him.
In all the previous examples, we proved that Mr. Incredible's super strength is unrealistic.